I run this site called Hacking with Swift, and you can just go and look at that online. I'm not going to preach to you about that here. Instead, I'm here to talk to you about SwiftUI being everywhere, because, of course, the promise of SwiftUI is that we can use one framework to build these same apps on all platforms, which is awesome. Love it. But it might sound somewhat familiar. In fact, back in 1996, we had Java saying you can write once, run anywhere. And it was revolutionary for its time, but it had all sorts of early problems, giving it the moniker, write once, crash anywhere. It's gotten way better since then. But you'll just tweet that one picture. It'll look awful now. Anyway. But since the dawn of the app world revolution, we've had folks telling us, you know, native code's dead. My thing, my cross-platform thing, whether that's HTML or Cordova or React Native or Electron, will totally eat your lunch. It'll take over completely. And here we are, 10 years on. Where are they? Where are they? So why does SwiftUI say write once, run anywhere, and we don't think, this is just Java all over again? And the answer is they've changed the equation. It is not write once, run anywhere. It is learn once, and apply anywhere. So they show us pictures like this at DubDub, saying you can share your graphics, you can share your foundation, you can share some UI, but the platform-specific UI, that's going to change. And they said this, you're still going to want to tailor your UI for each individual platform to ensure your app feels great everywhere that you deploy it. So it's not saying the same code everywhere. Instead, it's saying the same concepts everywhere. You may learn how things work and why. You may share your models and your networking, and of course, you'll share a lot of your UI code, but not all of it. So in today's talk, brought forward early, just for you folks, we'll talk about what's easy in SwiftUI, what it makes harder, and what are the interesting workarounds / hacks we can put in place to make our life easier. So here is the classic DubDub DC example of SwiftUI. Building an app in just a few minutes. This is a simple single-view app template using SwiftUI. It's basically blank. We can go ahead and say to this thing, I want to replace that text with a list counting from 1 to 50, taking a number in, and for each item, show a starship number. And boom, it pops in as a scrolling table. We can move around freely. Of course we can. That's SwiftUI. Then we can say, actually, we don't want to go in below the clock. It looks hideous. We want to put that list inside a navigation view. We have some space at the top, keep it away from the clock and the safe area. Pushing it all inside, add a brace at the end, and boom, top right will appear a little gap, into which we can now write a navigation bar title. We can just add a modifier to our list saying, your title is going to be Stan's Shipyard. For any Monkey Island fans in the audience? I'm old, sorry. So it's Stan's Shipyard. We could say, hey, it looks quite boring as it is. How about we add some images to this thing? We can say, get the image for our ship number, the thumbnail. Then use a clip shape using a capsule. And it'll snap in and look great straight away. Great, there's our list done. How about a detail screen? Well, let's make one of those. Make some space above the content view because I'm being lazy. I'll call this thing detail view because again, I'm being lazy. Tell this thing your ship number as an integer. And then inside the body for this thing, all we're going to do is say there's going to be a vertical stack of content down the line, starting off with the bigger version of our ship image. Below that, we're going to say the title of the ship, which is just starship number, whatever number it was. In a nice big font, I'll use large title. Below that, we'll have a more text field below saying available to rent now. And I'll use the font for this one, headline, so quite big, but not as big. Below that, we'll add some more text. And I'll just fill in some lipsum text in here. Then copy and paste it a few times, sort of pad things out nicely. And say, that text, I want to have some padding around that so it doesn't go quite edge to edge. And add a spacer below it so it gets pushed to the top. And a navigation bar title, saying just like your selection. So that's our detail view. And now to push that, we can go back to our original view. And we can say, I want to take the text and that image. I want to wrap that inside a navigation link. So it will point to our destination of the detail view with the number that was tapped. Then just push it all in, end the brace. And immediately pops in disclosure indicators. Tap on those things, and in slides your new screen with a large title, a picture, some padded text, and more. This is basically the canonical example of SwiftUI working on a dub stage. It's amazing, it's the future, hurrah. And it is very good. And one of the things I love is you saw me doing fonts there, large title, or headline, or subheadline, or caption, or more. And that's because SwiftUI respects dynamic type out of the box, as default, as standard, which I love. What it means is, when we go into our list here, those fonts look great. And I go to the overrides for our environment next code, I can say, hey, how do these look bigger or smaller? And see immediately scale up or down, because it looks great for all sizes of dynamic type. And it also looks great if I customize that font a little bit. I could say, I want a Starship number, yes, but I want a slightly nicer font. I'm going to have a font using the system font. Again, I'll give this thing title, but I'll ask for a serif font, little edges on the font. And it snaps in like that. And again, that again respects dynamic type. It looks beautiful. Turn it on, drag it around, things scale up and scale down. Amazing. SwiftUI, hurrah. Love it. But what if we said, this is the Starship, this is Stan Shipyard, not an old world font here. We want a super futuristic font here. And of course, when you're reaching for the future, you reach for Futura. So we can go into our code again and take out that font and say, I want to use the font with a custom font. And I'm going to use Futura Condensed Extra Bold. I'll choose a nice size, 24, nice and big. And with that in place, there we go. Let's go ahead and scale up and down, make sure it all works nicely, and nothing happens. So SwiftUI works great with dynamic type if you use SwiftUI's fonts. If you don't, use your own fonts, your own custom fonts, which of course your designer is saying, please use our company fonts. It doesn't work. So what we've got to do here is say, okay, well, we really need dynamic type. I hope you all support it. It's so important. We've got to do better than this. So we can go back to our code again and add a special extension. We can say we're going to make a thing that's available only on iOS and Mac Catalyst and tvOS and watchOS. And there's going to be a custom font view modifier. And this thing's going to have inside it an environment that reads the size category, which is dynamic type settings, plus the name of the font to load, and the size of the font to load. And inside there we'll say what we're going to do is transform the body we're given, the content we're given, by first going into UI font metrics and ask this thing, here's the value they asked for. If we scale that up to where it should be based on their dynamic type setting, what should it be? And it'll say, well, here you go. Here's a size for that scaled value. We can then use that with the existing font modifier from SwiftUI, saying whatever font they chose, custom font with the same name they asked for, at the scaled size, having gone through UI font metrics. And as you can see there, we have this environment reading for size category that is not being used in the body. But that's okay. As soon as you have any kind of struct that references the environment or external object, SwiftUI will reload it automatically when it changes. So as dynamic type changes, it now knows to reload our view modifier, thus scaling the font. And of course, from there, the smart thing to do is just below this thing, add another extension available only to iOS and Mac Catalyst and tvOS and watchOS, because it's not very nice using custom modifiers. What you want to do really is have an extension on the view protocol that creates a custom view modifier for you, which I'll just call custom font at name string and size CG float. And all that does is wrap our custom modifier in a nicer to call way. I'll just return self with the modifier of our custom font modifier, passing in the same data. But it makes it easier to use at the core site, as you'll see. So now we have the modifier struct and our custom extension on view to use, which means we can now go back down to our original list, where we have our hard-coded custom font at size 24, which we don't want, of course. We can now replace that with our custom font instead. So we'll just say instead, dot custom font, there we go, boom. Remove some parens, call it name, awesome, like that. And now when it runs back, it respects dynamic type. Beautiful. So, custom fonts. They work. They aren't cross-platform. You don't get macOS support with kind of hard-coded UI font metrics directly in there. So, rating, not nice. It's not pleasant. That's the kind of thing that this should really support out of the box, but does not. You've got to do it yourself. Let's say your designer comes in with some new design tweaks, and they say, well, we want this app to look much more colorful. What I want you to do really is make this list have a nice, bright background color. So, okay, fine, I can do that in SwiftUI. It's easy. I'm going to say below the title is a background color of red. Super bright. As you can see, look at that lovely red background color. Completely ignored. SwiftUI is like, yeah, whatever. It's got its own plans. You can't do that. We could say, hey, actually, those cells, I'd like those to be blue. Make those blue. So I'll say to this one, let's make this background color blue. And it's like, okay, I'll kind of half give you that one. And it looks grim. So we can't have that. It's not allowed in SwiftUI to use those currently. We're going to delete those modifiers and instead add some more hacksaws. We're going to add an onAppear modifier that says, if we are only able to do UIKit stuff, then use the appearance proxy for table views, set the red background color, and the same table view cells. This time with blue. And of course, it looks gorgeous, as you might imagine. So you're only going to do that kind of thing on UIKit supporting platforms like iOS and other platforms, tvOS. But it kind of works. It kind of works. So it works if you want all your table views to be exactly the same color. It's not cross-platform. This will not in any way work on macOS or watchOS. And for rating, just no. It looks terrible. Don't do that. And you might say, hey, I saw that amazing WWDC keynote. There's some cool features now. First, let's go ahead and ditch this hideous red and blue and go back to that navigation view we had. You might say, listen, I saw the WWDC keynote. I know we now have SF symbols to work from. So I'm going to go ahead and ditch that custom image we had and instead use those beautiful numbered circles we get from SF symbols. It has 1 through 50 exactly, hopefully, like I planned ahead. And you can use those instead. It snaps in, 1 through 50 appears as these little circles. So you get SF symbol support out of the box in SwiftUI, which is amazing. And best of all, this thing works fantastic on iOS, and fantastic on watchOS, and fantastic on tvOS, and even fantastic on macOS. Just kidding. Does it even fractionally work on macOS? Although, annoyingly, most gallingly, it does work on macOS if you build an iOS app and use Catalyst. Then it works. So SF symbols does not work. It's not cross-platform, damn it. And for the rating, I've learned a fantastically important Italian phrase, mi fa cagare. For the non-speakers, there's an emoji for you. So, it really can feel sometimes like SwiftUI is out to get your code. It's going to find you and hunt you down and harass you. It's a horrible framework. But the truth is that there are some things you've seen that make it remarkably easy to use SwiftUI. It's wonderful to use in so many places, but other things are so much harder. It's not a silver bullet, it's a balancing act like so many other things in our platforms. The problem is, right now at least, it's really hard to predict, to see ahead what those things might be. Now you might think, I'll just use Catalyst. Build my iOS app, put it on Catalyst, and boom, we're done. We get direct type, we get table view appearances, we get SF symbols out of the box. And it's true. But Catalyst will only make a handful of changes to your content. If you have an important Italian word like ciao, it'll say, well, listen, on iOS, the default font size is 17. On macOS, it's only 13. So we'll scale things down by 13/17 to about 77%. So it'll scale your things down to be smaller, which is nice. But that's about it. So you want to make your app look great, Catalyst won't do a brilliant job. And we can demo that with SwiftUI, which of course works with Catalyst. Here is a blank app again in SwiftUI. And we're going to start off with a very, very simple example. This is for iOS, as you can see. I'm going to go ahead and say in here, there is some state tracking a selected number. Pick a number, right? And we'll use that with a navigation view, with a form, and with a picker. And it will say, go ahead and select a number, being bound to that property, so it changes that thing. Inside, they'll count from 0 to 100, and then just print out the number. So it'll print 0, 1, 2, 3, 4, up to, in this case, 99. And then add a title at the end saying forms. And the layout gives us that. It's absolutely beautiful by default. Tapping it, new screen slides in, check a new item, it slides out, and is selected. It looks great out of the box. This is a real power SwiftUI feature. Now, what we can do is, if we go to our project and check the box marked Mac, it's going to add Catalyst support to our application. I'll go ahead and say yes, build the thing, and you can see how it looks on macOS's default Catalyst build. It looks like that. We've got a split screen very nicely. Tap on a thing, go ahead and choose stuff. It does a really good job of going to Catalyst. But is that how we pick things on macOS? Not really. So we can go back to our code. And in our content view, let's make some space. We can go ahead and just select the form. Take the whole thing and swipe across here to a new macOS project I've got. As a native macOS project, give it the same state variable, also being default by default, and just paste it into the body there. So it's the same code. It's the same thing. I'll add one tiny change, add some padding around it so it looks a bit nicer on macOS. Otherwise, it's the same thing. And that's identical code. But now it's running a macOS native SwiftUI application. And now, when I build and run the code, what you'll see is that kind of picker. That is what macOS pickers look like. The SwiftUI adapts more intelligently than Catalyst does, which of course it does. It's being rebuilt from scratch for macOS, even though the code's the same. So that is a basic picker. We can go back to iOS again and try a different kind of picker. We can make some space below the first one, say there's another picker. Again, just select the number, bound to the same property. This time I'm going to loop over a handful of values. We'll say for each 0 up to less than 5. Put the text out again. But this one, I'm going to say, is a segmented control. A UI segmented control on iOS or NS segmented control on macOS. So we're now segmented control. Otherwise, the same logic, the same picker, yada, yada, yada. And again, this is running on the Catalyst version of my iOS app. And when that runs, what we'll see is a UI kit style picker. It's gray, it slides around as expect. And that's perfectly usable. You know, if that's what you shipped, I'd be okay with that. But it's not the way AppKit does these things. AppKit segmented controls look different. So again, we can go back to our code, and we can say, I'll just select all that code again, that whole picker, boom, swipe across to macOS, and then paste that below the first picker, like that. Exactly the same, segmented picker style, and similar. But now when it's built natively for macOS, we get the AppKit style segmented control. Identical code. This is a better job of looking native. So that's segmented controls. We can look at one of the more obvious ones, the more sort of striking ones, I think. If we make some space below that picker here, we can say, give me a toggle. It's a UI switch in UI kit land. And now, this is going to have, like, toggle me inside it. Now, on macOS, this will be an NS button, but on iOS and Catalyst, it's a UI switch that happens to run on macOS. And again, it looks fine. I'd be okay with that, but it's not the way macOS users choose true or false values. Instead, we go back to our code again and select a toggle, take it out of there, swipe across to macOS, and just paste it in. Again, identical code. Nothing's changing. We now get the macOS way of choosing these Boolean values. A checkbox. Of course it is. That's what we expect to have. It's on or it's off. And sometimes the UI of these things really is quite strikingly painful in Catalyst. For example, go back to our code again, and we'll add a different kind of picker this time. A state to track this, and we'll do @state var selected date is the current date. We'll make a date picker. So I'll scroll down here, and say below this toggle is a date picker. Saying select the date, bound to that thing. Otherwise, nothing else. So now we're doing a picker for dates. And on iOS Catalyst, we get this sort of table view cell thing, which when tapped pulls out spinning wheels, which you can't click and drag. You have to sort of swipe your way through with your trackpad. You can see it showing a year in the top in the blue, but there's no way to change the year. So you want to go back 3 or 4 years, you want to swipe to get RSI. So that's the way iOS does it. Of course it is, but it's not ideal. We can do better than that. If we go back to our code again, just take out that date picker and swipe across to macOS and see how macOS does it. I'll get the same property, of course. @state var select the date equals current date. and then paste in the same code below at the end of our form. Now we have the macOS AppKit version of the date picker, which by default looks like this. You just type values directly into there. I want to have the 4th of the 1st in whatever year you like. So it's much, much faster for users to work with. And actually on macOS is even a better date picker option. It's not available on other platforms, sadly. It's macOS only, which is a graphical one. Anyway, Catalyst is good. I'm not going to lie. What we get, Catalyst is beautiful. It's a great job. But if you want the best, then you've got to go native. Don't try and take your SwiftUI app and put it over to AppKit. Instead, say, I'll just take my code into macOS, the native app, and use it that way. And add the workarounds as needed. Or as Apple says, tailoring to make your things feel great on those platforms. And it's simple, simple things. For example, here's the Starship list app I made earlier running on macOS. You can see the orange background kind of glows through the sidebar, because that's how macOS gives a little hint this window's active. And to do that, you just say it has the list style, sidebar list style. That's all you've got to do to get a nice effect. So think ahead. How do you handle those list styles? How do you handle on iOS, or watchOS, Digital Crown, or the play pause on tvOS, or right-click on macOS? These native little components that exist only on certain platforms. So SwiftUI gives us the ability to make our apps look fantastic and feel fantastic on each of Apple's platforms. But how does that apply to custom UI? It's not just tables anymore. What does it look like? And helpfully, actually, they're both based on the same core animation, same metal underbelly. The same core is identical, which means actually it's easier to do custom UI than it is to do built-in controls with some hacks, as you'll see. Well, tailoring, we'll call it. So here's an app I'm working on right now. It is called Foods of Italy. Everyone loves Italy, Italian food, right? The whole world is Italian food. And I've gone through and I've picked out all the finest foods in Italy. And when this app runs, if I just press load examples, you get a swipeable list of stuff here. So there's pizza, there's lasagna, and then if you go further, there's, focaccia and so forth. Delicious, amazing Italian food. Mwah, love it. Anyway, always play to the home crowd. No, it is God's own country, Italy, tell me. Anyway, so there's our app. And the code for this, it's really, really simple. I can go to the content view for this thing and walk through it really fast. We have a navigation view at the top. We have a Z stack for doing overlapping of content. We have a button in the middle to load examples. It has a bit of styling, so it looks a bit nicer on the screen, not default. Then below that, we have this horizontal scroll view, so we can scroll through foods. It's like there is a H stack of content. And then for each thing in our menu, show a food view. And at the very end, we have that navigation bar title, saying Foods of Italy. And that's our main view. That little food view, that's not terribly hard either. It has at the top a couple of V-stacks, then the image of the food in question, the name of the food in question, the description of the food in question, and then at the end, a frame so it sort of sits at a certain size on the screen. So that's our basic layout. Now, there's not a lot going on here, but what I want to do is investigate taking this thing to macOS. So I'm going to go ahead and add a target specifically for macOS as a macOS app inside our existing project. I'll just call it Italy Mac. And when that builds, we're going to get a content view that matches macOS default. That's the default macOS content view right there. And it has text hello world, a random frame. We don't want that. We want our app. So I'm going to go ahead and delete the default macOS content view and instead say, I want our source code and our JSON. That stuff should be in the target for macOS. Add that directly to Italy Mac. It's now in both targets. I'm sharing the code directly rather than trying to make custom stuff in different files. So now we've done that, we can go back to our assets, add them to the macOS target, of course, because macOS wants to have images as well. Here they are. Just drag them all in. Boom. There we go. And then over in our content view again, we can go ahead and look at how this works. So as a reminder, this code works great on iOS. Compiles out of the box on iOS. It was built for iOS. But it's not built for macOS. As a result, when I build it again, we get a build failure with one of the classic SwiftUI error messages. Protocol type any cannot conform to view because only concrete types conform to protocol. And that bit worked fine before, but now it's not happy. If we scroll a bit further down, we'll get a hint as to what's going on with another wonderful error message. down here, Z-Stack, some view that it has no member navigation bar title. So now we're getting towards the root of the actual problem here. Navigation bar title is an iOS thing. This modifier only exists on iOS and I think tvOS as well, not on macOS. And it's actually on watchOS as well. So we have to count on macOS as the key. It's not available here, so we get compile error. So we've got to try and think around that. Now, I'm trying to share my layouts. I'm trying to not have custom thing for macOS, custom thing for iOS. So one thing we can do here, a little tailoring, working around /hacks, is we can go down below our content here and say, if we happen to be compiling for the Mac, then I want to have a custom extension for the View protocol. It will have our own navbar title that just does nothing. It'll return the same thing it received. But it just passes through what it got. But only for macOS, because it'll work elsewhere. And with that change, that's a small change, it'll now use our existing override rather than the built-in, not available on macOS problem, and so this code will compile. And we can actually run it. And there it is, as you can see, just like iOS. This window, I can't resize it vertically, but I can horizontally for some reason. It's not great. In fact, it sucks. We're going to fix that. And what's happening here is, on iOS, of course, your phone isn't going to change size based on your UI. It's a fixed size, so it'll be stretched to fit. On macOS, windows do resize. So it'll scale the window down to fit the content. What we're going to say now is, actually, our main Z-Stack, this thing, can be scaled. Has a frame with a max width infinity and max height infinity. So it can scale freely. And that small change now means take up as much space as you want. A little bit, lot, doesn't really matter, it's all good. And so we run the code again. We should now see the window looking pretty good. I can go ahead and load stuff in there. There's our sort of content kind of working. I can resize the window. But what you'll see there in the corner is this sort of thing I can just drag out. Yeah. What's happening there is SwiftUI is being helpful. It said, well, you've got a navigation view, so clearly you want to have some sort of detail thing going on here. We don't. We only want that on iOS. We can go to a detail view perhaps later on, or if we have a title. macOS, we don't want that behavior. We want to ditch that. So what we want to do is tailoring. We're going to go back to our thing again and say, actually, I'm going to have a custom iOS-only navigation view. Now, this is going to use the view builder system from Swift 5.1 to say, I'm going to store some content that comes in using view builders. This is a closure. I'll assign that thing to my content for later. And then, when it comes time for me to render my own content, if I happen to be on iOS, brilliant. Use a navigation view, and then put my content inside that. But for all other platforms, I'm going to use a VStack with no spacing, and then my content. So on iOS, we'll get that. And what it means, we can now use that thing for navigation view or VStack just by saying it's an iOS-only navigation view. So try and keep our code in one file here. So now this navigation view will be either existing or not existing, depending on the platform you're running on. And so now, being well, on macOS, we get our load examples, which you can press, and that bar's gone. It's kind of looking better. So we're getting there, bit by bit. But our UI isn't finished. Of course, you can't see what's going on. A designer comes along and says, well, listen, this is an app about Italy. It's got to feel Italian. It doesn't feel very Italian right now. What we're going to do is we're going to add the tricolore here. Flawless Italian. And we're going to a linear gradient at the top of our VStack. And I'll say this gradient is going to have the important colors of green, white, and red behind the button. And we'll say this thing's going to start at the top and finish at the bottom. And with that, we get this gorgeous now UI. Looks beautiful. Gorgeous. And of course, this is just core animation. This will work great on iOS. We can go ahead and change our target back to iOS. We say, yeah, go back to my Mac iOS again, choose iPhone 11 Pro Max, build it again, and we'll get, of course, the same layout. But it's not quite as nice, right? Because it's got the safe area, got that bar at the top. I don't really want that in there. I want this thing to go edge to edge to really feel the Italianness shine through the app. So what we can do is we can go back to our code again and say, well, I'm going to add a modifier here, edges ignoring safe area all. Go edge to edge regardless of safe area. And now on iOS, it looks Great. Goes absolutely edge to edge. And you're thinking, oh no, I can see what's happening already. He's just broken his Mac code. Yes. Well, Mac code. We can build it, we can run it, and it works great. Ooh. If you ever wanted confirmation that Apple's got a secret new laptop with curved screens coming up, there you go. It can ignore safe area in macOS SwiftUI as well. So it works great there too. So we can now go back to our code again and say, that button isn't quite right. I'm going to customize it slightly. I'm going to say it should be a borderless button style to remove the sort of inner macOS ugly button. That's the default on iOS, not the default on macOS. So we're saying make this the default everywhere. It's cross-compatible, and the buttons now look good everywhere. So we have posh cheese on toast and tasty cheese Jenga and so forth. So there are our products looking very nice. Tasty Italian food. Now, we can go back to our code again and say, this can look better. Because we've got the full power of core animation here. We can go to our food view and say, actually, it's hard to read as it is. I want to say this description. Some of these foods, I want to be a surprise, let's say, right? It's because some Italian food's not necessarily what you expect. Description, I want to make sure this thing's not visible by default. So to do that, I'm going to say this thing has some sort of state showing description. I'll say it's false. And with that in place, we can now use that to modify our description with some modifiers. We can go down here and say that if our description here has a blur radius, if we're showing description, blur is 0, otherwise blur is 5. And for opacity, if we're showing description, opacity is 100%, otherwise 0.25, so mostly invisible. Like that. So it'll change the blur or the opacity of the view based on that single Boolean. And then we can say, I'm going to attach to this whole stack an on-tap gesture that will, with animation, toggle the Boolean. Like that. So I'll change the Boolean. And now our food starts out faded away, and tap on it, fade it in, and learn about Italian food, because Italian food is fascinating. We can go a bit further and see, casu matsu, what's that? Turns out cheese with maggots. No one told me. A bit further, we have financiera, which is rooster testicle stew. Anyway, so I don't judge. Eat your food. So in our code, we can now say, hey, actually, I want to add a nice background behind this. I'm going to use a white color. I'm going to apply a shadow directly to that white color using a nice black shadow with a little bit of opacity. Let's do like 50% opacity. The radius, I'll do 100 points. No X and no Y. It's fine as it is. And I'll draw a nice white background shape behind our views, so they're now easier to read. There we go. So there's pizza, lasagna, there's a nice shadow behind it now, so it looks really nice and clear on the screen. We can swipe across and admire the delicious food of Italy. Yeah, lovely. Oh, what's that one? Cecche fritte, blind baby eels. Lampredotto, cow intestine sandwich. Great, great. The lesser known of the touristic Italian foods. So, now the nice thing is we can add in between those V stacks more advanced effects like a geometry reader, which lets us do screen reading of our position and scale and size on the screen. So we can put that whole code into that geometry reader, end the brace there, and then add another modifier. We can say here after the background, I want to have a rotation 3D effect. This thing takes an angle plus an axis to work with. The angle's quite long, so I'll make a little bit of space on the screen. And the angle, what we're going to do is calculate our position on the screen. We're going to say the degrees of our double's position on the screen, min x, globally. Take that, divide by 10, a little bit of it, and divide it by also the size of our screen. So you get a little bit of a modifier here, and rotate around the y-axis, which is kind of going down vertically. Now, with that simple rotation 3D effect, what we're saying is change the rotation of this thing based on its position on the screen. And so with that simple change, we now get a cover flow style effect on macOS. So as we load these things, we can swipe through and then scroll through in 3D. It's super nice. And that kind of thing works brilliantly out of the box, guaranteed on iOS as well. We can go ahead and change our target, go back to the iPhone again, run the code one last time, and we see exactly the same cover flow style effect out of the box. And that's exactly the kind of SwiftUI code you can get really, really easily. That's what it's best at, doing really custom, advanced, interesting, metal-driven user interfaces. Let's wrap up. If you'd like to learn more about SwiftUI, I have a whole book on it called SwiftUI by Example. You can go and download a free copy at that URL, if you dare type it. You've got 10 seconds. Take a picture quick. 10, 9, 5, 3. I'm ruthless, sorry. But as you've seen, SwiftUI can really, really let us use the same skills to build great apps everywhere. We learn once and apply those skills anywhere. But it does have its own set of problems you've got to work around or think about ahead of time to get the best of it. Catalyst is an amazing technology that can help overcome those problems, and it gets you great results quickly. But for the best results, optimize your app for SwiftUI. Thank you very much.